programs, I'm very gratified that anybody is here at all before 10 o'clock. The program calls for the meeting to start at 10 o'clock for some reason, which I don't understand, but that's okay. Because the meeting starts at 10 and the first talk is at 8. Thank God I'm not responsible for the conference. Thanks a lot. So I would like to welcome all of you to SPS 2018. This is both an auspicious year for this event and a propitious moment in the history of space solar power, I believe. Today, we will be doing more of the working meetings. So it's an introductory session until about 10 o'clock. We're a little bit later because we're making a late start. A workshop in the second half of the morning on a very important topic of spectrum for long-range power beaming. Justin, did you sign in? Okay, good. And then luncheon, and then this afternoon another workshop on the topic of focused on an International Academy of Astronautics decadal review of the subject of space solar power. And I would like, in advance of that discussion, to just say that if you would like to become a member of the Academy study group, this study just got started in March at the Academy meetings at the end of the month as part of the International Program Committee meetings for the International Astronautical Congress. If you'd like to become a part of that study group, please go to the sign-up sheet and make a little star or little circle and a check mark, something to denote that you're willing to be on the distribution list and that you're willing to be part of the study group. Exactly, that one. And Joe Rusher has the sign-up sheet that all of you should have signed up on. And obviously you don't have to do it until late in the day if you want to have a look at what the study group is doing first. So with that, Gary, do you have any opening remarks that you'd care to offer?
I'd like to welcome you all here, and really the objective, I think, from my perspective with respect to this seminar and the symposia, is that we all walk away with something more that we can do to move things forward. I think you'll see a lot of presentations that show things opening up, a new range of opportunities before us, and it's up to us now to engage and make something real of it. And on with the show.
Thank you, Gary. And so we will begin with the presentation by Darel Preble. There we go. Okay, Darel.
Thank you.
Hello?
Let's see. This is one of the activities of the Space Solar Power Institute. I don't know how many of you are familiar with the Space Solar Power Institute, but we work with a number of universities. This is this should be blown up better. Let's see. I do this. Probably goes full screen on that. Down here. Is that it?
Looks like it's right there, just up above it, just a little up.
No, I don't think that's working. We'd like you to be able to see these shining faces.
don't forget to mute your cell phones, please.
Do you want to try it again, the box in the screen in the lower right-hand corner? One over. Nope, not all that. Go to the left of the, right there, down below.
No.
No, no. You're a Windows person.
See if I can rescue you here.
Okay, rescue us. Had the pleasure of meeting Rom last night. First time I've met somebody from the electric power industry over here.
That's it.
That's all you got.
That's all I got. Okay, we'll work with what we got. This is a Professor Durgan, and this is the work they're engaged in. This is a presentation I did last month over at the Aerospace Department. And, this was last year. This is next year at WISI. Now, these are the advantages of space power, which we'll get into a little bit. I assume everybody's familiar with these advantages of space power. First question that you usually get in trying to figure out the cost of space power is, what is the cost of space transportation? If you can answer the cost of space transportation, you can pretty much answer the cost of space power. That's the largest, I'd say, unknown box right now. This chart I originally got from Gordon Woodcock. He created the learning curve on the right, looking at the military and government vehicles from some years ago. But about the year after he brought that out, Elon Musk put a new dot on the curve with Falcon 1. This is just one launch of the Falcon 1, not any reusable launch vehicle at all. So we're looking certainly at a new curve, but this is the curve that you're going to be working against when you're trying to say, what is the cost of space transportation? Obviously, it's too high right now, no question. But as soon as you start ordering the massive quantities of space transportation necessary to build space power, you're going to slide down that curve quite rapidly. There are already 4 billionaires, I believe, working on this pretty hard, not to mention a few other nations. So, there's a dot down there by Roger Angel, probably the most eminent telescope designer in the country. He predicted how to, he was going to shield the Earth from too much sun with these small reflectors using electromagnetic launch. To me, there's absolutely no question that once you get a company working on space power, chartered, subsidized, to pay off the massive cost of getting started down this curve, you'll see the cost of space transportation. It's already starting down that curve with the large constellations now being planned. Folks like Elon Musk predicting $10 a pound about 6 years ago. But I don't want to spend all day on the launch industry, because the Compendium comes out every year, which gives you some nice information, by the way. If you've never been to the AST's Space Launch Compendium, It comes out every year and gives you a lot of annually updated information. With the shift from the old ways of looking at launch to the new administration, processes of how this is allocated among various government departments and commercial groups, we're beginning to see some important shifts in the administration, the business arrangements, in critical technologies. The Department of Commerce, for example, is gone down and started down an important road of how are we going to manage both commercial and public-private industrial technologies, and especially things like space power. Trump has already begun putting policies in place which are going to facilitate this, you can see. Don't want to interrupt anybody while they're... Oh, see any interesting numbers on there? Let's see, an alpha. That's Leo. These are orbital launch vehicles.
Top button.
If
You stay at the mic and use the laser pointer, you're better
by
off.
the mic, you'll be able to get your voice on the recording.
Okay. I'll try to stay by the mic. Let's see. Laser pointer, yes, hooray! Let's see, Stratolaunch. That's supposed to do their first flight this summer, which we're all eagerly anticipating. And Mr. Bezos, he hasn't been as aggressive in announcing his prices yet, but we're looking forward to the price competition which is unfolding as we speak. Talking with the chair of the WSI conference that will be in Huntsville in December, he had a project with NASA that was going to the space station, and they had planned to launch it on a NASA vehicle, but it ended up at the last minute they couldn't do it, and they went to a Japanese vehicle, which was interesting arrangement how these things are unfolding. These are the number of launches. That's not a reflection, by the way, of the number of satellites, because they're, of course, pouring in satellites by like marbles, I think. But I would encourage you to go out and look at the annual compendium. It's a lot of interesting information they gather every year. This is the global space economy, 344 billion. Interesting breakdowns if you're doing marketing of what's going on. Let's see, that's television industry contributing that.
Darel, does that include reality television?
It includes everything the government is aware of in the space industry.
Can you give us a color code? I can't remember either.
Need to stay here. Well, of course, it's a pie chart, and it tells you, I think, the colors are labeled. New satellite industry up here. Okay? So you have to look inside. There's a U.S. government budget, and this is a non-U.S. government budget. So I assume that is U.S. companies that are commercially involved in the satellite industry. So you can break down, say, the government. There's NASA. Let's see, I think you'd want to see a DOD breakdown. Let's see. Satellite industry. NRO. United States Air Force. There's NOAA. I don't actually see directly the DOD.
Air Force is the DoD executive agent for space.
Okay. There's a lot of segments, though. I mean, it's classified stuff, you know, like in our national reconnaissance stuff. But anyway, all these slides will be available. And we have a BFR coming. And right behind him, the Blue Origin. Some big rockets. I don't think anybody's quite topped the Saturn V yet. They're working on it. Reaction engines. They're been receiving last month $37.5 million from Boeing and Rolls-Royce and BAE. So the Sabre jet of reaction engine Sabre for the Skylon is continuing to move toward production, I think. Slow process. I don't know if everybody's familiar with the Skylon. The Sabre engine will be capable of reaching speeds of Mach 5 while operating as a jet. And then by shifting the configuration of the engine, it changes to air breathing technology. And flipping to rocket power, we can get to Mach 25. I might mention the UK space industry laws recently passed are intending to bring the global space industry to UK soil. I assume that includes Australia, probably.
Darel, question. Could Mach 25 be translated to,
Orbit.
yeah, but to G's force on the body?
No, I don't think you can get
No?
that information out of it. You might guess, but I don't think you can derive that directly.
Velocity, not acceleration.
Okay.
Yeah. Most of these, like the space shuttle, never went past 3 Gs. I mean, you can go in the thrill machines and get 8 or 9 Gs if you want high acceleration.
Once is enough.
Strato launcher, as I say, it's supposed to be launching sometime this summer. First flight. They've rolled it around. Lurking in the back, you got the Navy's emails, which is under a shakedown cruise currently. That's, I believe, the Gerald Ford class. The advantages of the emails when they brought it out was they really were forced to, because the new heavier fighter jets could not be launched with the old steam engines. The other advantage of the emails is that it can also launch very, very light aircraft, like drones or whatever. And it is dialable, so you can put as much muscle into it as you want. It's a pretty slick system. I think they're shaking it out so they can put it on some more carriers. Unfortunately, it looks like there's increasing tension as we look forward to the Middle East, I guess. There seems to be plenty of military activity focused on the Middle East. At some point, we do need to consider, we don't want to end up fighting over the last drop of oil. Why don't we spend the money, going towards space power and get a much larger, much more plentiful source of energy? Hello, Dick. But unfortunately, these things unfold together. This is probably why there's so much focus on the Middle East and their oil. This is a chart of the cost of producing that oil. This is Saudi Arabia, down around, I don't know, 25 bucks a barrel. Iran, Iraq, Kuwait, Northern Africa, OPEC, UAE. You can see the Middle East well represented in the low cost of production, which means the most profitable oil areas in the world. I think Gail Tverberg got me this chart. If you've never been to her website, Our Finite World, she keeps up with the oil energy nexus, I guess. Since we get about 85% of our energy from oil or gas or coal or something. I saw where India is expected to surpass the United States in coal burning a few years from now. They're aggressively moving forward. France has signed, well, they've begun work on a 10 gigawatt nuclear installation in India. Be the largest in the world. A lot of people are concerned about this is the Arab Spring revolt, rising price of food. Saudi Arabia cut off a lot of their funding for Egypt's many people. This is a bigger picture that people sometimes fail to focus on, and you can't not focus on this if you want to understand what's going on. It all begins with the environment. This is a picture of salt marsh. It's the most productive agricultural land that we know of. It's a nurseries for shrimp, crab, fish, scallops. I like to keep salt marsh. Georgia is noted for having virtually all of their salt marsh intact. Not quite all of it, but from the environment we get our energy, of course, petroleum and so forth, which drives our economy, which again affects the environment. There's a lot of pieces, of course, to all this. The bad news is California's grid is falling apart. The good news is California's grid is falling apart. So, of course, it's bad because during 2017, California had 438 outages, which is a little better than last year. They had 470 last year. For 9 consecutive years, they've been leading the United States in the most power outages. By the way, Texas is the largest producer of electric power. A lot of heavy industry in Texas. 31% of those outages were of unknown origin. 24% were faulty equipment or human error. All of our presentations in Atlanta, the Power and Energy Society, this year have been given by engineers who have just returned from California trying to fix the California power grid. 2 of them are from NERC, National, I forget all. It's a federal agency concerned with the reliability of the power grid. The other one is from GE, recent Georgia Tech graduate 5 years ago, working on the inverters which are required to get power from, say, a windmill or terrestrial PV into the grid to synchronize it. So you can use that pseudo-random intermittent power on the grid. And talking with the fellow who presented last month, I guess it was, he was assuming that the input to that inverter was continuous. I pointed out to him that it'd be better to assume that it's not continuous because none of those renewable power sources are providing flat power. It's all power going like this. The inverters are all designed basically for rotating machinery, synchronous machinery, which is a flat, I don't know, flat current. But that's not what they're being forced to deal with. California has 256 subsidies, policy incentives, and encouragements for people to put windmills or solar up. 256 different policies and subsidies. If you're in California, that's how many you can look on your menu. Now, what do you suppose the cost of all this regulation is? 256 different ones. It's bizarre. I mean, it's ridiculous. I mean, why would we be subsidizing windmills and terrestrial solar? I mean, these are old technologies. They're not new. They really shouldn't be subsidized. But of course, if you're aggressive in attempting to reduce global CO2, and you know very little, or maybe you do know a lot about that, that's what they're pushing, of course. Yeah, it's cheap and easy. Yes, sir?
5-minute warning.
5 minutes, okay. Moving right along. Transmission access charges going up because of the poor utilization of the transmissions lines in California. This is the famous debate which Christopher Clack pointed out Jacobson's 100% renewable decarbonization plan is ridiculous. Does not hold water in his words. Whereupon Professor Jacobson sued Clack and the National Science Foundation for $10 million, which eventually was dropped when they filed countersuit using anti-SLAPP grounds, which, by the way, stands for Strategic Lawsuit Against Public Participation. It's embarrassing that science has gotten to that level. I testified 3 years ago about effective control of rising CO2 is not financially feasible for even large power electric companies using currently available technologies and RPS constraints. These companies and customers are not capable of shouldering the heavy substantive and procedural burdens, their wording, as their visceral connection to our global economies prohibits deploying grossly non-economic and reliability reducing power generation technologies. Spaceable power is required to effectively address rising global CO2. Energy consumption. By the way, you don't see many renewables up there. After $2 trillion, well, probably $3 trillion we spent chasing that. Basically, we're doing nothing on the massive scale required. This is a couple of recent recessions. Who knows, maybe another one soon. Fish catch declining, let's see. Dead zone in Mexico, off the Gulf of Mexico. Reliability is a problem. Their number one concern in the power industry. The nutritional aspects of climate change impacting all of our food. Of course, we make a lot of bad choices eating anyway. The big choice everybody's making in the power industry is toward gas. Gas is cheap right now. However, they did the same thing back in 1998, whereupon it went to $14 per million BTU at the Henry Hub source. We're looking at a similar trap right now, and no one knows what the price of natural gas or coal or oil is going to be even next year. But undoubtedly, we'll see more adventures in these prices. 1 minute? Okay. Thank you, Gary. This is details of what actually drove that. You can make liquid fuel out of, if you've got the power. This is some of the Japanese work. And I'm hoping that we'll hear from Mr. McSpadden about the frequency campaign for space power, orbital debris. I don't really have time to go into all this, but looking at the lowest cost bulk energy storage is CAES. But if you compare it to an energy return, energy investment, you get about 71 times more energy looking at the just energy return from space power than you do using stored things like CAES. That's just storing it one day. And that's not adequate. I mean, you can easily have a week of bad weather, cloudy weather. Same thing with the wind. There's no wind blowing in the summertime a lot of times. Okay. Any questions before we conclude? Did that, Ron?
Sometimes it'd be good to try to have a continuation of what you didn't have time to finish now, to discuss some of the issues. I think that's covered all the things I've been working with for many years.
Well, I hope we can do that. Thank you.
Thank you very much. Don? This is Don Flournoy, who will offer a few words about his background, and you've got 25 minutes.
All right,
Go ahead.
sure.
And your slides are underneath that PowerPoint symbol down in the lower left. Just click on it and put your cursor over it and your title slide will come up. No, sorry, it's the PowerPoint slide, just to the right down below you, and over to the right just a little. It's the one with the P.
The taskbar.
And the taskbar at the bottom.
Bottom of the screen,
Okay.
Taskbar at the bottom of the screen.
orange P to the left. Ah, you got it.
There we go. Hey, come back here.
Gary won't leave this, Darel won't leave the stage, that's a problem. There we go. Metaphorically, at least.
To the left, to the left. That one should do it.
Yep.
Outstanding.
Okay. All right. I've been looking around this room, and it really makes me happy to see that you are here. It pleases me to know that each of us made a decision to come here to Los Angeles and that others will be arriving shortly. It is reassuring to realize that those I consider colleagues, and there are many of them here today, care enough to make the effort year after year to get together, to learn, and to share what we know about this very special topic, space-based solar power. My guess is that not all of us, in fact, perhaps only a few of us, are here today because of a job description that requires our attendance. As for myself, I am a university professor, now retired, who runs a working farm out in Ohio. I have no difficulty finding other things of importance to do. But for the last 16 years or so, I have been captivated by the idea that we as a society, we as a planet, might learn how to live without fossil fuels. During this time, I've had the good fortune to serve as editor of an international journal. It's called the Online Journal of Space Communication. a journal that I believe is making a difference that matters, or has over that amount of time. I'll tell you just briefly something about this journal. This journal was founded in 2002 in conjunction with the Society of Satellite Professionals International, SSPI. Are we not working?
Is this clicker, is this the one that you were using?
Down there, okay. That's probably going to do what you can do.
Can you do it by hand?
Use the, click on that dot
With your finger or?
with your finger, yes.
Okay. I'll let Jack that.
Okay.
This is
All
my,
right, all right.
my son Eli.
You go ahead. We'll,
You might, are you going to be able to control it from there?
Yeah.
All right, that's good. When you get as old as I am, you need help. The journal I was introducing to you was founded in 2002 in conjunction with the SSPI. The SSPI, its initial focus was on communication satellites, that's ComSats, as you undoubtedly know. But our journal is now also closely aligned with the National Space Society in its publication of research and visualizations related to power satellites, that is, sunsats. I'd like to say a word about what our mutual interest is between satellite professionals and the space interest for purposes of space solar power. Since its founding, the Space Journal has embraced the mission of informing a global audience about emerging developments related to space, and our initial focus has been on such ComSat applications as voice, video, and data communication. About 10 years ago, our editorial board, consisting of the SSPI group and some academics like myself, made a major shift.
come a little closer to the mic.
Okay? That shift was the addition of energy as an additional theme of interest in our publication. Energy drew us into a partnership with the National Space Society, and because the NSS was holding annual conferences, such as this one, that included topics related to space-based solar power, and was publishing space solar power content on its own website, the SSPI agreed that we should seek a partnership, and we did. We talked to the NSS about who we should add to our editorial board, looking for people who would be knowledgeable about energy from space. To take charge of this new journal, we had the very good fortune to bring out of retirement Ralph Nansen. Nansen, in the 1970s, headed the Boeing company's team of scientists and engineers who had spent something like 8 years investigating space solar power. As a Boeing man, NASA had been involved in the Apollo program and the design of the space shuttle. He also had written 2 books on space solar power. Since our journal was established as an open source of credible information accessible via the internet, our journal became immediately popular domestically as well as internationally. Access to the internet and to our content made that information free. And we also tried to write it in plain English so that it could be read by a general, educated audience. Ralph Nansen. I remember the first National Space Society conference I attended. It was held in Orlando, Florida. I think the year was 2009, and some of you I know were present. I remember meeting Darel, Preble, Seth Potter. I remember the research presentation of Dr. Feng Shu, whom apparently is not able to be with us at this time. He is now the chair of our current Space Solar Power Committee. And I remember the energetic discussions that went on and on. And I was so impressed with what took place in Orlando that I have attended all international space development gatherings since in places such as Alabama, Chicago, San Diego, Toronto, Washington, D.C., Puerto Rico. I maybe have missed a couple. These were the years I was myself a program officer in charge of a series of university-related experiments testing the capabilities of NASA's new Advanced Communication Technology satellite. You remember that event? ACTS, A-C-T-S. It was the world's first all-digital satellite. And it had switching spot beams and rain fade correction capabilities. ACTS opened a whole new band of frequencies in the Ka band. Even then, 10 years ago, we were thinking about how ComSats, communication satellites, might deliver energy on this type of satellite using spot beams. Spot beams. By coincidence, later in the same year, I was invited to Beijing to co-chair an international conference on space information technology with Dr. Li Meng, Vice President of the China Academy of Space Technology, which is, as most of you know, is China's NASA equivalent. The title of my address at that time was Solar Power Satellites, our next generation of satellites delivering the sun's energy to Earth. On that occasion, I was invited by Li Wang and others to come over to Space City, home of the China Space Academy in Beijing, to make a presentation on a topic of interest to the CAST research team. What was that? That topic was U.S. R&D, the history of space solar power research. I agreed to lead this seminar under the condition that CAST would be equally forthcoming about its own research. As it turned out, that meeting revealed almost nothing that I didn't already know from the international media. I enjoyed the company, I enjoyed the exchange of ideas about space solar power, but I didn't learn a lot about China. But 6 months later, the China Academy senior staff sent me a document for publication in our space journal entitled Solar Power Satellites Research in China. The first official and public notice of China's space solar power strategy and schedule.